Alrighty, so what we're going to do now is we're going to get into a demo. So let me flip over to my VM. I hope everybody can see that. And we're going to open up my Management Studio. And we're going to have a look at, here I have my Data Warehouse, AdventureWorks Data Warehouse 2012 database. And I have some tables in here. And you can see that this thing's a little slow. Then I have two tables here. One is called the fact reseller sales, and one is called fact reseller sales with that I'm going to build the ColumnStore index on it. And if you can see, the size of the data here is about 7.8 million rows, and the index on a normal fact reseller sales table is about 3.5 gig, right? And the table itself is 1.8 gig. Sorry, I'm just trying to get my thing here. So what we're going to do is I'm going to open up these tables, go and have a look. I've already created a ColumnStore index on the table here, and I can show you the code that I used for that. I just created you say create non-clustered ColumnStore index on that table, fact reseller sales CS, and you specify the columns that are going to be included in that index. And in general, you include as many columns as you like. Some people will include all the columns. I do have a best practice on which columns to choose later in the webinar, so we'll go over that. If we look at the other table, fact reseller sales basic table, this table has all these standard indexes that come with AdventureWorks when you install the default sample databases. And they include things like you know, employee key and order day key and all of this good stuff. So they do have covering indexes for the queries that we're going to do. I have a question from Jeff that says, can I have a ColumnStore index without the underlying row store fact table? You can put a ColumnStore index on a heap, sure. You don't have to have any other indexes on the table. But remember that ColumnStore indexes are only non-clustered indexes, so you can't try and make it a clustered index. So the underlying table will still be a heap. Okay, so what we're going to do now is I'm going to show you some of the performance increases that we get with ColumnStore indexes. I'm going to set my statistics time on and my statistics IO on. And let's select distinct from a reseller product key from fact reseller sales. And this is going to take a while because, I mean, it's a 8 million row table on a VM running on my laptop. And we'll be able to see what the data is when it comes back. And then we'll be able to see the performance increase when I do it against the ColumnStore index table. So there it ran in about 25 seconds, and if we look over here, it did about 55,000 logical reads. Okay? Now what I'm going to do is I'm going to do this.
Hi everyone. Hi everyone, please bear with us for a second. I know we're having some audio issues. One moment please while we try to get them resolved.
Nope. There we go. Am I back yet?
Yeah, you're back.
I saw my audio disappeared there for a while.
You're back.
Okay. So let's go back to, I'm going to clean out the procedure cache and the buffer cache, and then I'm going to do the same. Select distinct product key, and product key is one of my ColumnStore index columns from my ColumnStore table, and This should be come back in a minute, in 1 second, and it only did 524 logical reads. That is much quicker. Okay, let's go and have a look at a little more in-depth query. This query is a sum of sales amount, and we're going to look at a specific order date, and we're going to order by sum, all that good stuff. Let's clean out the procedure cache and everything, and then let's first of all, let's go and have a look at the estimated execution plan here. And you can see here that this, what it's going to do is it's going to do a table scan. It has to do that because it has to do a sum, and it has to collect the top 10. Okay, then it does an aggregation, compute, and then it does a top. But it has to do this major table scan. Let's get that running. And that's going to take a while. So I'm going to have a look at some of these questions. Question from Jeff. I'm asking, Jeff, sorry, you're asking if the data is duplicated. You understand that the column store is greatly compressed? Yes, the data is duplicated in the way that when a column store index is placed on a table, it copies the data and puts it into a compressed column store column separately from the underlying fact table. I hope that helps your question there. Alrighty, so while we are looking at that, there's more. If it compresses, would it remove the duplication of the data in the table? Yes, that's how it compresses it. It basically stores one value in the column store index for each value in the underlying table. And then it has a reference that says which rows are referenced by that one specific value in the column store index. Secondly, there's another question that says, are there primary keys on the tables that you are querying now? There are no primary keys on the fact reseller sales. I think it's because there's no clustered index on these tables. As you can see here, oops. There's no clustered index on those tables. So when we did this query here, we got the sales amount. It's just one number. But we got back in about a minute, and it did 228,000 logical reads.